All right, so our lesson today, we're just going to continue looking at angles and determining angles. So last class we talked about a right angle is 90 degrees, and we talked about a straight angle is 180 degrees. So anytime you have a straight line, we know a straight line is 180 degrees, right? So if I just have a straight line like this, we know that this angle going like that is the 180 degree angle. All right, so here we also have a straight line. Just forgot to draw the arrows, but straight line going horizontally. And part of our angle, we see this obtuse angle. We call obtuse angle is greater than 90 degrees. So this angle here is 135. So it's easily, we can easily determine angle X by taking 180 degrees, subtract 135 degrees to give us the answer of 45 degrees. All right, so very important to remember those special angles we had talked about last class. All right, let's take a look at our next example here. So notice again, it is a straight line going across like this. That means that again, if we were to go from here all the way to here, it has to be equal to 180 degrees because it is a straight line, so therefore straight angle. In this case, we're given this section here is 62 degrees. This section here is given as 48 degrees. We have to calculate X. So similarly to the previous example, we can take our 180 degrees because we know a straight line is 180 degrees, and we can subtract from it the 62 degrees, subtract from it the 48 degrees, and we can get the leftover section, X. All right, so 180 minus 62 minus 48, that would give me 70 degrees. And again, it is important that you do state here what X is equal to. So here, first example, our X was equal to 45 degrees. Our second example, X is equal to 70 degrees. All right, so we're looking at this example next. All right, and right here we have the little square. So we know that little square represents a 90 degree angle. So we know this part here is 90 degrees. All right, if we had made a full circle, it would be 360 degrees. So to figure out this reflex angle, we just have to do 360 degrees, subtract the 90 degrees, and we'll get this section here. Right, so 360 subtract 90 gives me 270 degrees. So therefore, in this example, X is equal to 270 degrees. All right, and recall a reflex angle is greater than 180 degrees, but less than 360 degrees. So that's a reflex angle right there. This example is similar to the first two we had looked at. If we know a straight line is 180 degrees, we can calculate X. So I'm just going to pause it here and let you guys try that one. All right, so in this question, again, straight line is here. This part is 63 degrees. From here to here is 63 degrees. So therefore, we can figure out X by going 180 degrees minus 63 degrees, which gives me 117 degrees. All right, let's try our next example. This one here. In this example, we are given this angle, and we have this little square in there. So we know that anytime we see this square, that represents a 90 degree angle. All right, since this whole angle is 90 degrees, and part of it we're given as 32 degrees, we can subtract 90 degrees minus the 32 degrees to give us our x, which is equal to 58 degrees. All right, so x is equal to 58 degrees. All right, and the reason being, we know that this angle plus this angle has to equal to 90 degrees because we're shown that little square there, which represents a 90-degree angle. All right, so let's look at this example here. So from here to here, we're told it's 70 degrees. All right, and from here to here, we know it's 169 degrees. So if you notice, we are making a full circle like that. All right, so all we have to do is, we know a full circle makes a 360-degree angle. We're going to subtract the 70 degrees. We're going to subtract the 169 degrees to give us the value for x. All right, so 360 minus 169 minus 70, and we get 121 degrees. All right, so x is equal to 121 degrees. Our next example here, we are looking at opposite angles. So last class we had talked about opposite angles and how congruent angles are formed when two lines intersect. So I'm just going to put this example here again from last class. So again, opposite angles, when two lines intersect, congruent opposite angles are formed. So 150 degrees is opposite from this one. So these two angles are congruent or the same, and these two angles are congruent or the same. So looking at this example, this is 72 degrees. The angle opposite is angle y. So because these are two lines that are intersecting, opposite angles will be congruent. Y will also be equal to 72 degrees. Now we have to figure out angle x and angle z. So because we know this is a straight line, okay, and this part here is 72 degrees, we can figure out x by taking 180 degrees, subtract the 72 degrees. So 180 minus 72, grab my calculator, gives me 108 degrees. All right, so now we've solved for x. We know that x is 108 degrees, and we know that opposite angles are going to be congruent, so therefore angle x and angle z are the same. So angle z will also be 108 degrees. All right, so looking at this example then, we know this is 130 degrees. Opposite from is B, so therefore B will also be 130 degrees. Solving for A or C, you can look at each line, this line here, straight line, right? So we know a straight line makes a 180-degree angle. So if this is 130 degrees, this will be 50 degrees, right? Because 130 plus 50 gives me 180 degrees. Now that we have A, opposite from A is C, so we can say that that's B is 50 degrees. Okay, let's take a look at this figure here, and we're going to use our protractor to figure out the two angles. So I'm just going to put it just like this, and we can see that there's two numbers going on top. All right, so the reason there's two numbers is because, or two lines of numbers, is because of obtuse and acute angles. All right, so this angle here is our acute angle, and we know our acute angle has to be less than 90 degrees. So therefore this angle has to be the 60 degrees. All right, so this angle is 60 degrees. Looking at our angle from here to here, this angle is our obtuse angle. It has to be greater than 90 degrees, so therefore we would use the 120 degrees. Okay, so once you have your measurements, then you can take this off, and we can here now put that from here to here was 60 degrees, and here to here it was 120 degrees. And because we know a straight line has to make 180 degrees, you can see that 120 plus 60 does give us 180 degrees. All right, so let's say we had to construct an angle, and let's say for this example, it's a 140 degree angle. So what you're going to do is you're going to start and you're just going to draw a line like so, and we'll just put a circle here. That circle is where we will put this part of our protractor. This part right here is where the protractor goes, just like that. All right, so now you can see 140 degrees is here, right? But that'll make an acute angle. And we know that 140 degrees is an obtuse angle. So we can't use our top number here. We have to use the 140 degrees shown here. All right, so just follow that line like that, and you just make a mark like that. And then you would take your straight edge like so, and just hold it and construct it like this. So from here to here now, we can say is 140 degrees. And we can also state from looking at this is that the acute angle made on this side is 40 degrees. And again, it totals 180 degrees. All right, so we're looking at this example. This is for Math 8, and this is what we're given. We have two lines that are parallel. Parallel lines are shown usually by these arrows like this. That means that those two lines are parallel. This line going through it, that line is called the transversal. I'm just going to label it transversal. And if this was line 1 and this was line 2, we can say that line 1 is parallel to line 2. Now, we're only given one angle. We're given an angle here of 65 degrees, and the rest of them we have to figure out. We have to figure out angle 1, 2, 3, 4, angle 5, angle 6, and angle 7. All right, but from our knowledge from last class, we talked about interior alternate angles, exterior alternate angles, and we also talked about corresponding angles. So we know that from those rules we talked about last class, we know that angle 2 and this angle will be the same, angle 4 and angle 7 will be the same, angle 1 and angle 5 will be the same, and angle 3 and angle 6 will be the same. As well, we know that a straight line makes a 180 degree angle, so from that we can also solve the rest of the angles. All right, so because we know angle 65 is here, we know angle 2 will also be 65 degrees. So angle 2 is equal to 65 degrees. All right, because of our rule of opposite angles, we know that angle 6 will also be 65 degrees. So 65 degrees, this is also 65 degrees. Angle 1, angle 3, angle 4, angle 5, angle 6, and angle 7. So far we've also figured out angle 6 is 65 degrees. All right, because of straight lines, we know straight line is 180 degrees. We take 180 and subtract 65. Therefore, we know angle 5 is going to be 180 minus 65, which gives me 115 degrees. So this here is 115 degrees. Because of opposite angles, we know this will also be 115 degrees. All right, so angle 5 is 115 degrees. Angle 7 is 115 degrees. Now, because of corresponding angles, we know angle 1 will also be 115 degrees. Angle 3 here, because of opposite angles, that will be 65 degrees. And then angle 4 will be 115 degrees.